Okay, we have finally reached the last part of our last example in Calc 1. This is example 86 in your class notes, and we have the last 4 parts of this example. Starting off with example E. Now we want to integrate x squared times cosine of x cubed. So this should, there really should be like a parenthesis around this cosine of x cubed. That does not mean cosine of x quantity cubed. So this is cosine of x cubed. There should be parentheses around this x cubed. People don't often write it that way. So when you see this, you have to understand that that means cosine of x cubed. All right, so the x cubed is inside the cosine function. So substitution is the technique we're using. So that's what I'm going to let u be. Let u equal that x cubed, that inside function of another function. So u is x cubed. So find du. Du then is 3x squared dx. So let's just take these two and go back and try to plug in. So this becomes cosine of u. That's good. Then I'm left with x squared dx. So I have 3x squared dx, so no big deal. What do I get to be left with x squared dx? I divide both sides by 3. So du over 3 is x squared dx. So my x squared dx becomes du over 3. That's great because that's just a constant 3 in the denominator, so I pull out a 1/3. Integral of cosine of u du. Very simple integral now. What function, if I take this derivative, gives me cosine of u? Well, that's sine of u. So this is 1/3 sine of u plus c, my variable constant of integration, sorry. Plug u back in, it's x cubed, so this is 1/3 sine of x cubed plus c. Okay? So now I'm going to get a little bit more complicated on you, but substitution will still work. So here in part F, I have integral of x times the square root of 2x plus 1 dx. So I'm using substitution. So I see, I look for a function that is inside of another function. So I see that the function 2x plus 1 is inside the square root function. So that's my u. U is 2x plus 1 because that's the inside function. So then just look at that u. Let's figure out what du is. So du is simply 2 dx. Okay, so then I come back and I just take these two guys and try to plug them in. All right, so what happens is I end up with u to the 1/2. That's my u to the 1/2. My dx, okay, I don't have 2 dx. I don't have another, I have x dx. So don't worry about the x for a second. Let's just look at the dx. So dx then, dividing both sides by 2 here would be du over 2. So there's my du over 2. The problem is I'm left with x. Well, the only thing I can do to substitute, get u in terms of x here is to come over to this original substitution where I let u equal 2x plus 1 and solve that for x. Then that gives me what u is in terms of x, right? I'm sorry, what the x is in terms of u, I should say. So solving for x, I get u minus 1 divided by 2. So I plug that in. That actually makes it look more complicated, but it's not, because there's nothing I can do here to multiply this x times these guys inside. But now these are just power rules to multiply these guys. So first of all, let's bring this 2 out and this 2 out, which are both in the denominator. That's 1/4. So bring out the 1/4. Then multiply u times u to the 1/2. Add exponents. That's u to the 3/2. Minus 1 times u to the 1/2. So minus u to the 1/2. So now look at it, that's a pretty simple integral, both of these. I break it up into 2, right? So u to the 3/2, I add 1 to that. 3/2 plus 1 is 5/2. Dividing by 5/2 is 2/5 multiplied. So it's 2/5 u to the 5/2 minus integral of u to the 1/2, add 1/2, add 1 to 1/2, I get 3/2. Dividing by 3/2 is the same thing as multiplying by 2/3. So it becomes 2/5 u to the 5/2 minus 2/3 u to the 3/2 with a 1/4 in front of all of that. And then add your constant of integration. You're almost done. All you have to do now is take u and plug it back in everywhere you see a u so you get your answer in terms of x. So simplifying 1/4 times 2/5 is 1/10. 2x plus 1 all raised to the 5/2 power. 1/4 times minus 2/3 is minus 1/6 times 2x plus 1 to the 3/2 power plus c. Okay. Now sometimes when you want to do functions like sine squared or cosine squared, we have to go back to what we learned in pre-calculus, and I bring it up here again in calculus. This is called a half angle identity, right? So if I know that if I want the sine squared of x and I want to reduce the power on this because I don't know the integral of sine squared of x, I only know the integral of sine x or cosine x, I need to reduce the power on this by this identity. So sine squared of x is equal to 1 minus cosine of 2x all divided by 2. If this had, by the way, been cosine squared of x, then it'd be 1 plus cosine of 2x divided by 2. This is using the double angle identity cosine of 2x and working backwards. But I would just memorize those or put them down on my cheat sheet. Sine squared of x is 1 minus cosine 2x over 2. Cosine squared of x, if it had been here, would be 1 plus cosine 2x over 2. Then it becomes simple. I have an integral of 1/2 dx. Pull out a 1/2 integral of minus 1/2 cosine of 2x dx, right? Because 1/2 goes with both pieces. And then this is cosine of kx, which we know the integral of that is 1 over k sine of kx. So that's another 1/2 sine of 2x. So I have 1/2 x minus 1/4 sine of 2x plus c. Okay? The other thing that might pop up, and I'm doing these trig identities because sometimes these pop up in your homeworks. H, we have 1 minus 2 sine squared of x times the sine of 2x dx. So the sine of 2x is good, its power is 1, but I have this guy, 1 minus 2 sine squared of x. So 1 minus 2 sine squared of x, by the way, turns into cosine of 2x. How does that turn into cosine of 2x? Well, remember that cosine of 2x is cosine squared x minus sine squared x from the double angle identity. But cosine squared x is 1 minus sine squared x. So cosine of 2x is really, another way to look at it, is 1 minus 2 sine squared x. Now that's a pretty good one. So I can take u, actually u could be either one of these guys. Okay, so I'm going to let u equal sine of 2x. So du is 2 cosine of 2x dx. So when I take these two, I try to plug it back in, I see that sine of 2x is u. Then cosine of 2x times dx, well, I just have a 2 in front of it, so divide by 2. So du over 2 is cosine of 2x dx. So it becomes integral of 1/2 times the integral of u du. Very simple integral, that's u squared over 2. So it's 1/4 u squared over 2 plus, 1/4 u squared plus c, and then u squared is sine squared of 2x. So 1/4 sine squared of 2x plus c.